Hello, we are the Legacy Biofuel team, and we'd like to showcase why our mission is one of the most important out there. Did you know that Colombia is sitting on an energy goldmine that we burn every day?
We produce 178 million tons of organic waste each year. Nevertheless, 83% of this goes to landfills without the energy being redistributed. During droughts, energy prices to our most endangered families can go from $30 to over $400 per megawatt.
I'm Nicholas, and with my teammates, Daniel, Elisa, Samuel, Julian, and Nicholas, we are Legacy Biofuel. Our mission is to transform trash into a decentralized energy vector for communities the grid left behind.
Our research revealed a deep structural lock-in to fossil fuels. Using the iceberg model, we identified that while the problem is visible high emissions, the root cause is a historical dependence on fossil fuels that started in the Industrial Revolution. Furthermore, this immense problem in Colombia is sustained by a say-do gap. Our system says it wants green energy, but governmental auctions awarded zero bioenergy capacity and room to grow, because they only look at short-term costs. Our system analysis further showed how industrial perpetrators and bystanders uphold this complex through implicit biases. This crisis is poisoning our lands and waters, and improper waste management leaches these chemical compounds into local ecosystems, while the methane from rotting organic corpses drives up all national greenhouse gases. For our citizens, this is survival. In non-interconnected zones, families are forced to deplete their life savings on expensive diesel just to keep the lights on during a drought. If we don't break this fossil fuel lock-in now, Colombia will lose its sovereignty, forced to import 70% of its energy by 2050, and leave the most vulnerable at the mercy of global market stocks.
UPB focuses on investigation, innovation, and formation, which was ideal, since everything they brought to the table for us was like gold. Their facilities, their teachers, their resources, and their intellect on the topics we were focusing on were the perfect match for us. We plan to target non-interconnected zones, or NICs, covering up 52% of Colombian territory, where 2 million people are sidelined by a system that sees them as not financially reachable. With our collaboration with UPB, we plan to take this innovation outside the test room to prove these areas don't need a massive grid expansion. We bypass the large bioenergy plants by pivoting to a small-scale, self-generating SSG under 1 milliwatt.
Legacy Biofuel Project addresses a global crisis where tons of foods are wasted annually, with 83% ending up in landfills where they release methane and CO2, contributing to warming as much as 15 coal-fired power plants. Fossil fuel production follows Hubert's curve towards depletion with an estimated 53.5 years. Our innovation converts school cafeteria food scraps into functional second-generational bioethanol to replace hazardous octane boosters like MBTE. The technical workflow begins with physical size reduction, milling and shredding to 0.5 to 3 mm to maximize surface area, followed by acid hydrolysis using diluted acids like H2SO4 or HCl2 to break down complex starches and cellulose into fermentable glucose. For maximum efficiency, we identify simultaneous scarification and fermentation as the superior bioprocess mode because it combines enzymatic and microbial steps in one vessel, reducing residence time and preventing sugar buildup from inhibiting enzymes. Economic success relies on 20% solids loading, which achieves the lowest production cost of around $1.57 per kilogram ethanol, even though energy and enzyme completion remain the most pronounced cost drivers, accounting for up to 81% of total expenses. Using the iceberg model, we identified that sustainable change requires moving beyond technical fixes to address the underlying structure of global capitalist economy and the mental model that resources exploitation is a necessary cost of development. Finally, our strategy creates a circular loop where post-fermentation solids serve as a high-phosphorus organic fertilizer and capture CO2 and can be reutilized for industrial purposes, achieving a truly zero-waste integrated biorefinery.
Now, we're currently executing about 20 kilogram runs of food waste to produce fuel-grade ethanol, which is about a little bit less than 96.5%. We begin with acid hydrolysis at ideally 143 degrees Celsius. We then move on towards a 72-hour simultaneous saccharification and fermentation cycle, using combined enzyme cocktails to reduce costs and speed things up a little bit. This practical work is then paired with our residue mapping database, which basically proves that yes, agricultural waste, like for example cassava stems, can achieve a 5-year payback period, making renewable energy a viable financial asset for, say, rural farms. Furthermore, we plan to extend our knowledge and chemical process to non-profit organizations. This will then allow our process and work to reach larger scales instead of the current small scale it resides in, and it would also allow us to help other communities, say universities or companies that have a more non-reusable way of dealing with waste. Unfortunately, due to scheduling conflicts and a lack of access to highly protected material, we were unable to complete our fermentation and distillation process to demonstrate at the ISE Project Fair. Nevertheless, with the help of our sponsors and our knowledge on the topic, we were able to produce an in-depth manual that takes the reader step by step through the process of making legacy biofuel. Furthermore, in addition to the manual, we've also decided to accompany it with a video that simplifies the process for spreading awareness instead of actually making the fuel.
So, after speaking with the people of the University of UPV, they told us, and we got some feedback from the manual that we gave them, that we have most of the planner incredibly well made and pretty much perfectly calculated. They did tell us that we have to focus on 3 small things. First of all, the type and the amount of acid that we're going to be using. If we're going to be using, for example, say 10 liters or 10 milliliters or however many liters of, say, sulfuric acid or hydrochloric acid or whatever type of acid. What we do have to keep in mind though is, apart from the type of acid, the amount of acid. Why? Because some acid are stronger than others. For example, sulfuric is stronger than hydrochloric. So if we're going to be, in the original calculations, going to be using sulfuric, but in the actual process we use hydrochloric, we have to make sure that the amount of hydrochloric acid that we use is equivalent to the amount of sulfuric acid that we were going to be using in the planner. Second, which actually combine the other 2 things, are with the organic material, how small we're going to process it to put it inside of the process, and the glucose level that they're going to have. Why? Because these 2 are the main factors that are going to be put into how efficient the process is going to be, first, and second, how good the fuel is going to be. Apart from that, everything is well done and our hypotheses are correct. We will be able to make the fuel that we expect.
The true impact of legacy biofuel begins when we leave. Our project is designed to be self-sustaining by leveraging Colombia's legal framework, specifically Law 1715 and Resolution 281, which grant rural communities the legal right to be their own power bosses at a small scale, self-generators, or SSSG. We aren't leaving them with just a theory. Our team operations manual serves as a permanent altitude-adjusted blueprint. It provides the exact protocols for acid hydrolysis, fermentation, and distillation, allowing marginalized communities to maintain their own decentralized biorefineries indefinitely. Our vision of a circular bioeconomy is achievable because we've provided the tools to turn local waste into local wealth. In conclusion, we have achieved all our primary ISE objectives. Community. We identified organic retail food waste as a high potential residue for campus-based systems. Sponsor. We've secured scientific guidance from UPA researchers to validate our 5-stage approach. Success tracking. We proved that residues like cassava stems are financially viable, boasting a 5-year payback period. And finally, scaling. We've transitioned research to the active production of fuel-grade ethanol. My personal approach is that hydrocarbons in Colombia are a thing of the past, and things like legacy biofuel and sustainable biofuels are the future for ecological, environmental energy in this country and in the world, which is why we need to provide these access to people of all wealth, of all incomes, and legacy biofuel is the future.
My personal takeaway from this process is that energy justice is a human right. So future ISE innovators, our advice is simple. Use systems thinking to find the root cause. A successful innovation must solve a human problem, not just a technical one, because a planet covered in trash is a planet that has lost its legacy.
Colombia has been dependent on fossil fuels and carbon for the longest time, and today is where we stop. Our legacy is the future.
My takeaway from all this just shows the electric inefficiency that we have not only nationwide but worldwide, and seeing how us, even as high school students, can do something to change that world and can potentially inspire others to do the same, therefore leaving our legacy in the world.
Takeaway on this project is I'm basically surprised and I'm honestly astonished as what you can actually achieve with food waste. I usually had this idea in my head when I was a kid that waste was waste and it was just meant to be thrown away. But honestly, I'm surprised in everything that we've achieved as a group, and I hope that what we do here will move on to become our legacy.
My takeaway from this project is that something as simple as trash can turn into something as valuable as energy, putting another step forward in our legacy to seize every idea, for crazy and unrealistic as it seems, and to always try to make the world a better place.